to continue from permutation involving letters of alphabet, but this time around we are going to look at conditions of permutation involving letters of alphabet. Conditions. So we have conditions in permutation involving letters of alphabets. Now, number one, if any numbers of letters must be together, if any number of letters must be together, comma, they should be taken as one. They should be taken as one, and then be added to the remaining letters. Then number two, if any letter or letters must begin a word, comma, that letter or letters should not be counted. Examples. 1. In how many ways can the word L be permuted if the two L's must be together, then B, if letter H must begin the word. Then number 2, in how many ways can the word statistics be permuted if A, the 3x must be together, B, if they must start the word. So let's take our solutions. So in the first example, we have the word L. So if you look at our last video, if there is no condition, if you are just asked in how many ways can the word L be permuted without any condition like if, you just go straight to it. 4 factorial because there are 4 letters over 2 factorial because the 2 repeated. But when there is a condition, you must follow the conditions. You must follow that condition. So in this question, there is condition. They say, in how many ways can the word L be permuted if the 2 L's must be together? Now, according to the law, we say that if the letters must be together, those letters should be counted as 1. So the number of ways if 2 L's are together is equals to 3 factorial. Now, the reason why it is 3 factorial because we say that if the letters are together, the 2 letters become 1. So altogether, we now have 1, 2, 3. So it's not 3 letters we have. The 2 L will be counted as just only 1 L and be added to the H and the E. So we now have 3 letters. So it's not 3 factorial. And 3 factorial is equal to 3 times 2 times 1. So the answer is 6 ways. That is when the 2 L's must be together. If the 2 L's must be together, our number of ways becomes 6 ways because the 2 L's will be taken as 1 and be added to the remaining letter. That is the 3. That is 3 factorial. 3 times 2 times 1, which is 6 ways. But if there is no restriction, remember what I said, if there is no restriction of together or something like that, if it is just in how many ways can the word L be permuted, we just count how many letters over the number of letters that what repeated. That is what we do. But if there is condition, you must follow the condition. Now let's look at B. B said that if letter H must begin the word. If letter H must begin the word, letter H will not be counted. If letter H must begin the word, if H must begin the word, H will not be counted. So it becomes H-E-L-L. H will be ignored. So the new word becomes H-E-L-L. It becomes E-L-L because the H will not be counted because it must begin. So the H will be stationary. It will not be counted. So the new word becomes E-L-L. So we are going to work with E-L-L because H will not be counted. Based on what we said, if any letter or letters must begin a word, they should not be counted. We should work with the remaining letters. So if H is not counted, what we are having left is E-L-L. So the number of ways for E-L-L is now equals to, so we say the number of ways for E-L-L becomes, how many letters are remaining for E-L-L? We have 3 letters, which is 3 factorial, and we have repeated letters over 2 factorial, which is 3 times 2 times 1 over 2 times 1. So this cancels this. So our answer is 3 ways. So this is our answer. So let's look at number 2. Number 2 say that in how many ways can the word statistics, good, statistics. So statistics. Yes, in how many ways can the word statistics be permuted? Roman figure 1 say that if the x must be together. Now, if the x must be together, all the x will be taken as only 1x. If the x must be together, our new word will be statistic. That is what we have. We just take all the x and take them to just be 1. The 3x becomes 1 when they must be together. If they must be together, the 3x become 1. So we have just statistic. So this 3x, 1, 2, 3. So only one x will represent them. Then the other letters will be there. So it will be statistics. So we are going to work on this. So it is this one we are going to work on. Is this one we are going to work on. So the number of ways is now equals to. So based on, we have said that if the letters must be together, those letters will be taken as only one. So the 3x here will be taken as only 1x. Then we still have the other letters, which is 1x for the 3x. 1x will be representing the 3x. Then our T, A, I, and C, they will remain in the formula or in the word. So what we are having is now statistic. So we are going to work on this. So in this statistic, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, which is 8 factorial, over. Then we have repetition. Some letters repeated. I repeated 2 times, so it will be over 2 factorial. Then T repeated 1, 2, 3. 3 factorial. So here is the same thing as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 is for the 2 factorial times 3 times 2 times 1. So if we cancel, this one will cancel this, 2 will cancel 4. So we are left with 8 times 7 times 6 times 5 times 2. So when you multiply them, you have your final answer. When you multiply this, it will give you the number of ways. So without wasting time, we'll look at the other question. So let's say the other question say that if the 3x must start the word, so we say that if 3x must begin the word. Now remember, so for the multiplication of this, we have 3360 ways. 3360 ways. So thank you for that. So for the Roman figure 2 of it, if the 3x must begin the word, so we say that if any letter or letters must begin the word, they should not be counted. So we have tick. So since the x must begin the word, it means that the x should not be counted. So we are going to work with the remaining letters, which is statistic. Since the x must begin, they should not be counted. Whether the x are up to 5 in the word, we will not count them. So we'll take the other ones. So the number of ways will become, the number of ways here will become 1, 2, 3, 4, 5, 6, 7, which is 7 factorial, over 2 factorial for the 2 i's, then 3 factorial for the 3 t's. So here it becomes 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 for the first 2 factorial, then times 3 times 2 times 1. So 3 times 2 times 1 cancel 3 times 2 times 1, then 2 cancel 4. So we are left with 7 times 6 times 5 times 2. So which is about 420. Yes, 420 ways. So 420 ways. Okay, now we are going to Okay. So